Section number 5 covers questions 6 and 7. It starts off saying, in an earlier exercise, you were told that a house is selected at random from Hector Street. The probability that the house has gas-fired central heating is 0.25. The probability that the house has off-street parking is 0.76. And the probability that the house has both gas-fired central heating and off-street parking is 0.19. Let G be the event that the house has gas-fired central heating, and let F be the event that it has off-street parking. A. Draw a Venn diagram to represent this information. B. Are the events G and F independent, and show your calculations that lead you to your conclusion. Alright, so I'm going to actually have to do this off to the side because I'm not going to have room in this space provided. So we're going to do 6A here. Alright, the first thing we're going to do, I'm actually going to do this in a Sharpie so that you can see it over all these lines, is I'm going to draw my Venn diagram, and I'm going to have my two circles, right? And one of these is going to be labeled F, and the other one is going to be labeled G. Should have put G and F, but that's okay. Okay, our gas-fired heating is 0.25. So I know this entire circle equals 0.25. Next, we have F, which is our off-street parking. That is 0.76. So this whole circle is 0.76. And it says the probability that the two events happen at the same time is 0.19. Okay? So the overlap is 0.19. That's A. B asks, are the events independent? Well, let's take a look. G and F independent. So I want to know, is the probability of G given F equal to the probability of G? And is the probability of F given G equal to the probability of F? All right. So here we go. Probability of G given F equals G given F. So that's going to be 0.19 over F, which is 0.76. Whenever I divide those, I'm going to get 0.19 divided by 0.76. This gives me 0.25. My question is 0.25 equal to the probability of G? Yes. So that's independent. Let's see if it works the other way. Sorry. We want to do the probability of F given G. So this time it's going to be 0.19 divided by 0.25. Well, 0.19 divided by 0.25 equals 0.76. Is that equal to 0.76 equal to the probability of F? Yes. So these are independent events. Because they were equal to each other. G given F is equal to G, and F given G is equal to F. All right, let's take a look at number 7. Number 7 says, in the country of Milapanami, 68% of the population do strenuous exercise, 50% walk for pleasure, and 21% do neither of these two things. When a person is selected at random from this city or this country, let E be the event that a person engages in strenuous exercise, and W be the event that a person walks for pleasure. Draw a Venn diagram to illustrate the information you've been given. This one I'm going to actually write down here. So we're going to do 7 down this way. A. So we're going to start off by doing a Venn diagram. I'm going to have 2 circles that overlap. One is going to be labeled E. The other one is going to be labeled W. E is going to be 68%. So we know that this whole circle equals 68%. W is 50% for pleasure. This is going to be 0.50. And 21% do neither of these items, so they're going to be in the box but outside both of the circles, 0.21. So here is my Venn diagram. Let's find B. B says, find the probability that a randomly selected person from this country engages in strenuous exercise and walks for pleasure. Hint, the addition rule could be used here to answer this question. Well, let's take a look. We know that the probability of E or W equals 1 minus the probability that they don't, right? So that's going to equal 1 minus 0.21, which equals 0.79. So either they walk or they engage in strenuous exercises is 0.79. Okay? The way to find the probability of E intersect W, the overlap, is to say, we know that the probability of E is 0.68 plus the probability of W is 0.50, and we need to subtract the probability of OR, so 0.79. So we're going to do 0.68 plus 0.50 minus 0.79. This is the part that should be in the overlap section. So this part right here is 39, just that overlap. Now that leads me to C. C states, are the events E and W independent, and explain? Well, I want to find the probability of E given W. Well, E given W is 0.39 over 0.50, because that's all of W. 0.39 divided by 0.50 equals 0.78. Since the probability of E equals 0.68, oh, sorry, this, hold on, let me fix that. I copied the word in the wrong spot, my bad. This should not say since the yet. It should just say the probability of E is 0.68. Now, here we go. Since the probability of E given W does not equal the probability of E. These two events are not independent. We could have also done it the other way. We could have done probability of W given E. Well, W given E would have been 0.39 over 0.68. 0.39 divided by 0.68 would have been approximately 0.58. That's not an exact because it went out to decimal places. So this would have been 0.58. And we know that the probability of W is 0.50. And we know that probability of W given E does not equal probability of W. So the same reasoning here. They're not equal, so therefore they're not independent events. On to the next section.